So in previous class, we discussed some about the Hadoop, and today we continue the discussion. And today we shall discuss the components of Hadoop and some other related information. We can have two kinds of computation, one centralized and other distributed. When we say centralized computation, that means processing is taking place at one machine. And when we say distributed computation, then processing may be taking place on several different machines, or it can be one form of also multiprocessor. If we consider the client server model, what we have, some kind of processing is to be performed, so client may submit data. And at distant place, the server machine may be, it perform computation and send back to the client. And then client get the necessary result or processed data. So you see here, centralized computation of data. Data is transferred from client to server and then computed. It is called centralized computing programming model. Similarly, distributed computing of data. Data is distributed along with computation tasks on different machines. It is called distributed computing programming model. Hadoop uses distributed data and MapReduce programming model. Now this MapReduce programming, it does not fully transfer the whole computation on all the machines. It does a major part by sending computation tasks on different machines and later on compiling them. So that technique, that programming model is called MapReduce. So we will see some discussion on MapReduce today, and in detail we will discuss later. So this is big data ecosystem architecture. Ecosystem, I told that ecological balance, just like nature has some balancing mechanism in itself. Our body also a kind of biological ecosystem. Okay, so if we try to define big data computation in terms of ecosystem, so this can be like this. Here we have data sources. Data is coming from different sources: human communication, human machine, machine to machine. And here we process data. So data ingest and stream processing, batch processing. This is file system. Okay, network infrastructure. So all this we call data ecosystem, big data ecosystem, and the data which is coming out, it processed for data mining, visualization, dashboard, report, such other kind of activities. So Apache Hadoop is a collection of open source software utilities that facilitates using a network of many computers to solve problems involving massive amount of data and computation. Computation is also very large, and data is also large. It provides software framework for distributed storage and processing of big data using MapReduce programming model. This, as I told, centralized programming model, and distributed programming model. Now this model we call MapReduce programming model. So all the modules in Hadoop are designed with a fundamental assumption that hardware failures are common occurrences and should be automatically handled by the framework. Meaning is that when we use network, then there are always chances of failure of communication link because of so many practical reasons. So in case the failure takes place, the communication is broken and the computation is also halted. So whenever network is involved, we always take care how failure can also be handled. So this Hadoop framework takes care if some kind of failure takes place, then it will automatically recover the required data. So once user write program and submit jobs, then all the processing responsibilities are taken care by the Hadoop system itself. User need not to be involved at any level. Only one time he submit program using MapReduce programming technique. So this Hadoop takes care for this fundamental reason or assumption. The core of Apache Hadoop consists of storage part known as Hadoop distributed file system and processing part which is called MapReduce programming model. Hadoop splits file into large blocks and distributes them across nodes in a cluster. It then transfers packaged code into nodes to process the data in parallel. This is packaged code. It is kind of computation program, you can say, a part of program or job or task. Okay, we will see what is the specific term. The base Apache Hadoop framework is composed of the following modules: Hadoop Common, Hadoop Distributed File System, Hadoop Yarn, and Hadoop MapReduce, and Hadoop Ozone. So Hadoop Common contains libraries and utilities needed by other Hadoop modules. Few libraries are such that which are required by many other modules of the Hadoop. So Hadoop Common, Hadoop Distributed File System (HDFS), a distributed file system that stores data on commodity machines, providing very high aggregate bandwidth across the cluster. Hadoop Yarn, it was introduced in 2012, a platform responsible for managing computing resources and resources in clusters, and Hadoop MapReduce, an implementation of the MapReduce programming model for large data processing, and Hadoop Ozone. So it is introduced only in 2020. The storage model of Hadoop, how it does define the model. It divides the whole storage in clusters, rack, node, and data block. A cluster has several racks, and in each rack there are several nodes, and each node has several data blocks. So this is the way of storing data and addressing them. The term Hadoop is often used for both base modules and submodules, and also the ecosystem or collection of additional software packages that can be installed on top or alongside Hadoop. And such are Apache Pig, Apache Hive, HBase, Phoenix, Spark, Zookeeper, Impala, and Loam, Snow, Scoop, OG, and Apache Storm. Apache, Hadoop, MapReduce, and HDFS components were inspired by Google paper on MapReduce and Google file system. First time Google implemented this Google file system, it was distributed file system and this programming model. Later on, working on the same line, these open source solution came. The Hadoop framework itself is mostly written in Java programming language with some native code in C and command line utilities written as shell script. Though MapReduce Java code is common, any programming language can be used with Hadoop streaming to implement the map and reduce part of the user's program. Other projects in Hadoop ecosystem expose richer user interfaces. To make further convenient of the use of this Hadoop, several these interfaces are proposed. This is one simplified architecture of Hadoop. So in any computer system, we have memory, we have CPU, we have input-output device like. So here you see one storage is required. So this is HDFS, distributed storage. So one major component is storage, that is HDFS. Other like CPU, we say processing. So this is MapReduce program distributed processing. This is one component. Okay, and this is another scheduler, yarn, yet another resource negotiator. This yarn came into Hadoop 2.0. In 1.0 version, this yarn was not present. Then Hadoop common, this is the Java libraries, utilities. So this architecture, you understand, architecture means just like building architecture we talk. So for a building, how various parts of the building, okay, and if somebody have to construct a big building, then he or she have to take help of architect. So architect decides where should be door, where should be window, how much dimension of the room should be, how much dimension of the hall, where should be bathroom, light, so many things. Similarly, in software, when we talk about architecture, that means what are the components, what are the parts, what is the function of each part, how one part or one module interact with the other. So all those, they are called software architecture. So this is simplified way of describing architecture. Similarly, this is another diagram. It is also showing you a simplified form of architecture. So here master slave nodes are shown. Master is the name node we call, and it also has a source manager scheduler. Okay, then they are the slave nodes, and here they have data nodes, they have node manager, and MapReduce programming part. So several nodes are here. So this is another simplified understanding for architecture. And you see this is also one. Actually, I am showing you different all simplified mode of explanation of the architecture so that you could have some image in your mind. So you see here DFS storage, this is allocator, yarn, and this is MapReduce programming, and this is the library. So all these three uses, all these three use the library and utilities to carry out the computation of this Hadoop. So four components of Hadoop. This picture is somewhat have more components. Okay. So you can see here, this is storage, HDFS, Java, HDFS. This is data storage framework file system, Hadoop distributed file system. It is showing data processing framework MapReduce. Okay. This is on Java virtual machine. And this is the operating system layer. Okay, this is some hardware. This is operating system layer, and here this is Java virtual machine. And on this Java virtual machine, this is storage, HDFS file system, and this is MapReduce programming, and this is the network layer. And on network, we have this several clients might be. So where are the clients here? Okay. So in this picture, clients are not appearing, but you can see HBase, Waka, Plume, Zookeeper, Orchestrion framework, BI application, query analytics, reporting, statistics. This is EDW connector, backup recovery, deployment security management. Few components are shown here and you might be aware, and few components you may not be aware right now. So those discussions we will take later. But we can access using these software. Okay, data access framework. So we will see later, but this architecture somewhat having more components, but you see core components are same: data storage, MapReduce. Okay. And easy understanding, this is somewhat easiest, okay, because you are already aware master slave. This is somewhat compared to previous one, somewhat complex, not much, but somewhat. It has the same, but it is also providing some understanding how all these have interaction with common utilities or libraries. Okay. This is showing you interaction with operating system, Java virtual machine, and network. And data access can be through these software. Okay. And they provide other functionalities. So Hadoop distributed file system is a distributed, scalable, portable file system written in Java for Hadoop framework. It provides a shell command and Java application programming interface, API methods that are similar to other file systems. So HDFS has 5 services as follows: node name, secondary node name, job tracker, data node, task tracker. First 3 are masters, service, daemons, node, and other 2 are slave services. These 3, name node, secondary name node, and job tracker. Name node is a master node and data node is its corresponding slave node and can talk to each other. In the new version of the Hadoop, we can have more than one name nodes. Okay. Name node, data node, and secondary name node, and job tracker and task tracker. They are five major components. Okay. So name node is the master node, and data node where actual data is stored, and there is one more secondary name node. Okay, and job tracker and task tracker. So HDFS consists of only one name node that is called the master node. The master node can track files, manage the file system, and has the metadata of all the stored data within it. In particular, the name node contains the details of the number of blocks, locations of data node that the data is stored in, where the applications are stored, and other details. The name node has direct contact with the client. Data node, a data node stores data in it as blocks. This is also known as the slave node, and it stores the actual data into HDFS, which is responsible for client to read and write. These are slave daemons. Every data node sends a heartbeat message to the name node every 3 seconds and convey that it is alive. In this way, when name node does not receive a heartbeat from data node for 2 minutes, it will take that data node as dead and start the process of block the applications on some other data node. So it waits maximum for 2 minutes, and more than 2 minutes, that means no data node is not alive, and it takes care about the application. So this is feature of this Hadoop. Secondary name node, this is only to take care of the checkpoints of the file system metadata, which is in the name node. This is also known as checkpoint node. Checkpoint means suppose if we divide time into several points, so at any specific point of time, what is the status of the, what are the values in name node? So that information is kept later at another point of time. So in this way, checkpoints they are maintained. So whenever any kind of failure takes place, from that point of time, we can have the recovery and we can initiate the system again. So secondary name node. So this is also known as checkpoint node. It is the helper node for the name node. The secondary name node instructs the name node to create, send file system image, FS image, and editing and edit log files, upon which the compacted file system image, FS image file is created by the secondary name node. Secondary name node creates this FS image of the name node, and edit log is also taken care. Job tracker receives the request from MapReduce execution from the client. Job tracker talks the name node to know about the location of the data that will be used in programming. The name node responds with the metadata of required processing data. Task tracker, it is the same node for the job tracker, and it will take the task from the job tracker. It also receives code from the job tracker. Task tracker will take the code and apply on the file. This process of applying that code on the file is known as mapper. Hadoop cluster has nominally a single name node plus a cluster of data nodes. Although redundancy options are available for the name node due to its criticality, each data node serves a blocks of data over the network using a block protocol specific to HDFS. The file system uses TCP/IP sockets for communication. Clients use remote procedure calls (RPC) to communicate with each other. So they are the communication protocol. HDFS stores large files, typically in the range of gigabytes to terabytes, across multiple machines. It achieves reliability by replicating the data across multiple hosts, and hence theoretically does not require redundant array of the independent disk RAID storage on host, but to increase input-output performance, some RAID configurations are still useful. With the default application value of 3. Default, we have 3 copies of each data node, each data block or data node. Data is stored on 3 nodes, 2 on the same rack and 1 on a different rack. Somebody can also take on 3 different racks. HDFS was designed for mostly immutable files and may not be suitable for systems requiring concurrent write operation. You see, there are few applications where most of the operations are read operations. Okay, so one time it is written, it never go on changing. So such files we call immutable. They do not have option of rewriting. So for such applications, this Hadoop is useful. So what kind of applications are suitable for it, we will see here. File access can be achieved through the native Java API. The thread API generates a client in a number of languages, for example, C++, Java, Python, PHP, Ruby, Erlang, Perl, Excel, C#, Coca, Smalltalk. The command line interface, HDFS UI, web application, HTTP, or via third-party network client libraries. Okay, so Thrift API is used. HDFS is designed for portability across various hardware platforms and for compatibility with variety of underlying operating systems. So different operating systems can be used here. The HDFS design introduces portability limitations that results in some performance bottlenecks. Since the Java implementation cannot use features that are exclusive to the platform on which HDFS is running. Due to its widespread integration into enterprise-level infrastructure, monitoring HDFS performance at scale has become an increasingly important issue. Monitoring end-to-end performance requires tracking metrics from data nodes, name nodes, and other underlying operating systems. There are currently several monitoring platforms to track HDFS performance, including Hortonworks, Cloudera, Datalog. These are to evaluate the performance of HDFS. So several parameters are considered. So evaluation the performance of HDFS is not straightforward. So monitoring the end-to-end performance requires tracking metrics. Several metrics have to be collected. Okay. So from data node, name node, and underlying operating system. Other file systems parallel to this HDFS are Apache Hadoop Ozone, FTP file system, Amazon S3, Windows Azure Storage, Bulbs file system. So they are compatible, HDFS compatible object store targeting optimized for millions small files. This stores all the data on remotely accessible FTP server. Amazon S3 object store. This is targeted at cluster hosted on Amazon Elastic Compute. If you go to Amazon site, it provides about more than 150 web services. Okay, and you can avail them. If you go and open your account and you can learn what kind of web services it is offering. Okay, few services are free for students or for this purpose, so you can also avail those services. But it will ask for your credit card number, etc. information. Only then you can access those services. And if you go, one more site is there, Mongo website, Mongo data website, MongoDB. There such condition is not that you require to give your credit card number, etc. And they allocate few resources free to you, and you can avail those services. So you can go and check it on MongoDB, but on other website, last year student also complained that they all first ask for credit card number, only then you can avail even free services. Windows Azure storage. So Elastic Server on demand infrastructure. There is no rack awareness in this file system as it is all remote. Windows Azure Storage. This is an extension of HDFS that allows distribution of Hadoop to access data in Azure Bulb stored without moving the data permanently into the cluster. Difference between Hadoop 1 and Hadoop 2. Difference is yarn. The biggest difference between Hadoop 1 and Hadoop 2 is the addition of yarn, yet another resource negotiator, which replaced the MapReduce engine in the first version of Hadoop. Yarn strives to allocate resources to various applications effectively. It runs two daemons. Daemons refer background processes. The system execute few processes and user is not aware. Okay, so those kind of processes they are called daemons. So it turns two daemons which take care of two different tasks. The resource manager, which does job tracking and resource allocation to applications. The application master, which monitors progress of the execution. So one main difference between Hadoop 1 and 2 is inclusion of yarn. Difference between Hadoop 2 and 3. There are important features provided by Hadoop 3. For example, while there is one single name node in Hadoop 2, Hadoop 3 enables having multiple name nodes. Okay, you can add more than one name node, which solves the single point failure problem. So in Hadoop 3, there are containers working in principle of Docker, which reduces time spent on application development. One of the biggest changes is that Hadoop 3 decreases storage overhead with erasers coding. Oh, less coding will be required here. Also, Hadoop 3 permits usage of GPU hardware within the cluster, which is a very substantial benefit to execute deep learning algorithm on a Hadoop cluster. ठीक है. Commercial application of Hadoop includes log or check stream analysis, marketing analysis, machine learning and data mining, image processing, XML message processing, web crawling, archival work for compliance, including of relational and tabular data. There is one theorem that suggests that out of three features, two features are present, then we can use so and so kind of technique that we will discuss when we have no SQL database. So now briefly I will show a few slides related to MapReduce, and the detailed discussion we will have later on this MapReduce. So this is just to this complementing Hadoop discussion. So MapReduce basic, each mapper processes single input split from HDFS Hadoop, passes developers map code one record at a time. Each record has key and value. Intermediate data written by mapper to local disk. During shuffle and sort phase, the values associated with same intermediate key are transferred to same reducer. Reducer is passed each key and a list of all its values. Output from reducer is written to HDFS. This diagram will show you. Map, then shuffle, then reduce, and out. So user write, map and reduce, and rest responsibility is taken here by Hadoop. This will give you some picture of MapReduce, and detailed discussion will be clear when we have. So it provides MapReduce automatic parallelization and distribution. It provides fault tolerance, status and monitoring tools, a clean abstraction for programmer. When we say clean abstraction for programmer need not to understand the internal details. Okay. Google technology roundtable. This is one Google technology. It uses MapReduce. So you can see what is the roundtable technology of Google, where it is used, and but it uses MapReduce. This is one simple example of MapReduce. Okay. What is the maximum minimum temperature for the last century? This is I will show you just a slide and discussion we will have later. So this is way how MapReduce operation programs are written. This is another example. Problem count the number of times that each word appear in the following paragraph. John has a red car which has no radio. Mary has a red bicycle. Bill has no car or bicycle. So this is server 1, server 2, server 3, 3 paragraph, and here it is at. So you see each word has its counting, and then server 1, server 2, server 3, server 1, 2, 3. So examples of this, you go to the video, examples are given. The student have written programs, and we will also discuss, but you can go through those programs right now and later you have better understanding. Hive is also one component, but it is not core part. Hive is a distributed data management for Hadoop. It supports SQL-like query option, Hive SQL language to access big data. It can primarily used for data mining purpose. It runs on top of Hadoop. It runs on top of Hadoop. Apache Spark, it is a big data analytics framework that was originally developed at the University of California, Berkeley, 2012. Since then, it has gained a lot of attraction both academia and in industry. Apache Spark is a lightning fast cluster computing technology designed for fast computation. Nowadays, Spark is used. Hadoop generally now it has become less popular, and Spark is now more popular. Apache Spark is lightning fast cluster computing technology designed for fast computation. This is Zookeeper. Zookeeper is a highly reliable distributed coordination kernel which can be used for distributed locking, configuration management, leadership election, work queue. Zookeeper is a replicated service that holds at the metadata of distributed application. Key attributed of such data: small size, performance sensitive, dynamic critical. In very simple words, it is a central store of key value using which distributed systems can coordinate, since it needs to be able to handle The load zookeeper itself runs on many machines. No SQL. While the traditional SQL can be effectively used to handle large amount of structured data, we need NoSQL or not only SQL to handle unstructured data. NoSQL database stores unstructured data with no particular schema. Each row can have its own set of columns. NoSQL gives better performance in storing massive amount of data. Apache Cassandra, it is a highly scalable, distributed, and high-performance NoSQL database. Cassandra is designed to handle huge amount of data. Cassandra handles the huge amount of data with its distributed architecture. Data is placed on different machines with more than one replication factor, that it provides high availability and no single point of failure. HBase is an open source distributed database developed by Apache Software Foundation. Initially, it was Google Bigtable. Afterward, it was renamed as HBase and is primarily written in Java. HBase can store massive amount of data from terabyte to petabyte. Spark Streaming, it is an extension of core Spark API that enables scalable, throughput, fault-tolerant stream processing for live data streams. Streaming data input from SDFS, Kafka, Flume, TCP sockets, niches, Spark ML machine learning functions, and GraphX graph processing algorithm are fully applicable to streaming data. So this is showing you Spark Machine Library is a distributed machine learning framework on top of the Spark core. Machine learning is a Spark scalable machine learning library consisting of common learning algorithms and utilities, including classification, regression, clustering, collaborative filtering, dimensionality reduction. Spark machine learning library components, algorithm pipeline, Spark graphics. Yes, I am closing was just.
Okay, sir. Thank you.
It is last one, I think. So this was about some related. Uh, it is brief discussion, and for detail, you have to go from individual website. And in subsequent classes, we also have discussion. So I stop here, and I advise all of you, first you go and install Hadoop, right? And you can also take help of the videos. Okay, thank you.